General relativity, step by step. Last screencast I established this particular identity here for this particular component of the Christoffel symbol for our trial metric for the cosmos. And it should be plain that this is quite a long and difficult error-prone undertaking to calculate all of them, all 32 of the different Christoffel symbols. And so what I'm going to do is to use a computer algebra system. And I've got Maxima here, got it set up here, and I will specify I will calculate all 32 Christoffel symbols. So first we've got to load C tensor, which is the package that calculates tensor calculus for us. We need to specify our coordinates, which are going to be t, r, theta, theta, and phi. There we go, and it's even typeset them in nice Greek letters there for us. Now I need to specify the metric tensor with in terms of LG. UG is the metric tensor with superscripts and LG is the metric tensor with subscripts, and that is going to be a matrix, and you specify it by rows or columns, it doesn't matter, it's symmetric. -1 0 0 0. What am I doing here? What I'm doing here is I'm just putting in this this matrix here, which is my metric tensor with two downstairs indices. Just a minute. Comma 0 a of t squared 0 0 for the next row. Next one is 0 0 a of t squared times q of r squared. Is that right? Yes. 0 close square comma open another square brackets 0 0 0, and now the final term a of t squared q of r squared sine theta squared. And then I need to, oh no, it's already closed the brackets for me. Here we go. And with any luck, can I scroll? No, I need to use this. Jump. It specified the metric with 1, 2, 3, 4 non-zero terms. It's nice and diagonal. We've got that minus, plus, plus, plus signature, which is quite nice. And now I can just calculate the Christoffel symbols. I need to go C metric. I think that does a whole bunch of calculations. C metric, there we go. Done, it says. Let me just bring this up a little bit. Here we go, so we can see it better. Now we specify Christoph MCS. And MCS, all that does is adjust the ordering of the elements. I don't really understand it, I have to say. Here we go. And in the blink of an eye, it's done it all for us. I guess the first thing to do is to verify that our calculation here was correct. And we can do that. We can go back to Maxima and scroll down and see. It caused me some difficulty. I thought it was this term here that was the first one here, 1, 2, 2, that was the one to compare, but it isn't. For reasons that are connected with this MCS business, it's this term here. It's the %T8. It's the 8th output here, which is A d by dt of A. So that checks out. So we've used Maxima to calculate the Christoffel symbols. And how many non-zero ones have we got? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 non-zero terms. So 12 non-zero out of 32, which is an indication that we've chosen a reasonably sensible coordinate system. Okay, so let's have a look and see. Well, let's try the rest of it. Let's see what else we've got. Let's try the Ricci scalar. Let's see if I can figure out the Ricci scalar. So we go Ricci, and I think we need to specify true. Here, done. Dear. Quite a lot of different calculations here. So it's 3. We've got quite a lot of complicated stuff. What I'm going to do is I'm going to stop here. I'm just going to have as a take-home message that this is quite a complicated process. We've got quite a lot of terms here for the Christoffel symbols, and we've got quite a lot of work to do. to calculate the Ricci tensor. It is a pain in the neck to calculate, but it's routine work. It's just very, very difficult, very fiddly and very error-prone work. So it's the kind of thing that you want a computer to do if you possibly can. I don't think you gain much in the way of direct understanding by evaluating these things by hand. But what I'm going to do is to use these formulas here and solve the Einstein field equations. But I'm going to stop here and do that in subsequent screencasts. Stop, stop, stop.